Right, oh, damn camera froze up. Flipping hate it when that does that. Right, I'm just looking for the I've got some actual bobbins here, look, that are, these are the small ones. I'm going to show you when I find this printout. I've got some 2 scale printout on here somewhere. Where the heck is it? Ah, maybe it's around here. That's not to scale. That's not to... Oh, flipping heck! I can't find the damn thing. Where is it? Hang on. If I can find it. I have a scale one somewhere. This one is not to scale, but basically the outside ones are like that. Right. And there's an overhang, the overhang of the edge of it, but the inside ones are shorter. But this one's not. This drawing, this printout is not to scale. I can't find the actual scale one that I did. I'll find it. Just a minute. Can you hear me, by the way? I don't believe this. I don't know where it's gone. This printout is slightly smaller. Right. You get the idea. These sit like this on the edges around the perimeter. These are the ones that go on the outside. The smaller ones go on the inside. Right. You get the idea. But these particular ones are you get the idea? I hope that explains how these sit on this actuator bobbin. This is basically how these sit. Right. Can you hear me alright? Hello? Oh, I'll just check my audio. Oh, is that better? Bloody microphone, it's acting up on me. Can you hear me alright? This is basically how these sit on the end of the actuator bobbin, right? These are what I already had printed. Now you can't. Oh, what the heck? Hang on a minute. Let me just choose a different audio input. Manicam. The Manicam audio, you mean this one? No, you want the Logitech. You mean this one? This one's too loud. Oh. Well, anyway, I'll leave it on there if that's what you want. All these different audio inputs. Right. Okay, I'll leave it on there if that's better for you. Well, you get the idea how these basically sit. You see, because this coil will be pulling on one pole of a magnetic field, and this other coil will be pushing down. So this coil will be pulling, say, south up, and this one will be pushing north down, and then they'll alternate, and then it'll be south down. It'll be biasing south down and pulling north up. It'll be switching the magnetic flux through the laminations, basically. So you get the idea. And the laminations will be well, I haven't got any laminations handy to my hand right now, but I don't know if I can show you with one of these, but I've already filed one of these out. Which one did I file out? Is it that one? I think it was that one. Well, I haven't got anything. These magnets are too wide to show you, but you know, the laminations go through sort of like down, sort of like that, you know. Right. Well, I think the dimensions are correct because of all I've really changed on these. All I changed on this drawing was the actual length. You know, the length, and obviously I put the wrong width, the wrong slot hole in on this one, but it's okay because Alan's using Alan's going by the by these drawings, right? These are the main drawings that Alan's going by. Right. And as I say, I already had these printed in the bigger lengths, and there was no problems because this is what the guy printed these that I have on my table. This is the dimensions, apart from the ones in red, which are the new dimensions for the shorter lengths, and I just deducted some numbers off both the end lengths and off, well, both the red, the inside measurements and the outside measurements. We're still maintaining that that recess for the coil windings, so I don't see any problem myself. You're loading an image. What image? I'll have a look. Just a minute, zoom in. Oh right, you're no, the bottom is not 5.5 millimeters. Right, you're saying that this here, this down here, 5.5 millimeters. Where the heck is that? Where you get? I don't know where you're getting that from. Hang on, 5.5 millimeters. Oh no, hang on. I think I know what you've got wrong. No, the bobbin. The bobbin is 16.5 millimeters. That way, right? The 3.5 millimeters is for the slot. It's for the laminations to go through inside here, right? Right. So laminations are the space is 3.5 millimeters right there, and the difference. Then there's a 2 millimeter wall, right? There's a 2 millimeter wall surface on this side, and there's another 2 millimeter wall surface on this side, which is the thickness of the surface where the windings go, right? And then the difference is what we have for the flange that comes out, right? The number you circle is the error. The height of the middle hole. Just a minute. Okay, let me have a look. $17. Right, let me just. Where's my calculator gone? Right, 30. That's the length there, right? Deduct the 17 off the that you're talking about, minus 17 equals 13, right? Now there's a 2 millimeter wall thickness for the surface of the bobbin that goes all the way around, right? That's on both the top and the bottom, so that's 4. So minus the 4, which is the wall thickness, right? Which is 9 divided by 2, which is 4.5. So there's 4.5. There's 4.5 millimeters between the wall of for the inside and the edge of this bobbin at the top. At the top, 4.5 from there to there. At the top and the bottom, there's 4.5. Okay. Then there's the 2 millimeter wall there, 2 millimeter wall here, right? So that 4.5 is consistent with what I've already got here on my what I've already had made. Right. Let me just put the other one on. That's the inside perimeter one. Let me just put the other one on. Oops, wrong one. That one. Right. Now, if you look at this one, this is a bit longer. The inside length is 35. Then we have the wall at this top. Sorry, I can't see this unless I do a screenshot. There's a 2mm wall at the top for the bobbin surface. 2mm wall at the bottom. So there's 2mm at the top and the bottom, right? So you subtract that from the 48. Then you divide it by 2. So, right, this is, let me just look at the chat, I don't know. The height of the, I'm not with it, I'm sure, so. Well, I'm a bit tired to be working this out at this time of night. All I know is I've got some 3D prints in my hands which work. Which work for the outside perimeters. Let me just measure them. I've got one in my hand here in the other camera view. If I switch camera views, it can crash my stream. So let me just measure this, what I actually got in print. Well, according to this, it's for these are ones that I've already had made. Let me just measure that if I can. Get, I need my magnifying glass. That's 4 point. Keep sliding around. Oh well, according to this, it's 5mm on the. Oh yeah, well I had these done. I'm changing measurements a bit since then. So there's 5mm. There's 5mm on this one I'm holding in my hand between the inside here, but that's because this the 3D prints tends to splay out and they're a bit rough. And between that surface there, right? There's 5mm on these. There's 5mm between there and the outside wall, the outside bobbin on each side. But these were made before I made some changes. So these, the total length of these is 48. These are actually 48mm long, right? So hang on, what's that? What I've got on my drawing. That's right, that's what that is, 48, right? So if you look at that, that's 48 on the picture, and the one I'm holding in my hand is 48, right? That's 48 top to bottom, right? That's 48, and the inside on this is a physical thing. The inside is, oh god, they're hard to hold. I'm trying to hold this and measure it. I've got my magnifying glass on because I've got to hold the ruler on the inside where the wire goes. Magnifying glass. I've got that lined up. Yeah, that's 48 point. That's 40. No, actually, that's 48.7. I think that's right. no, sorry, 30, sorry, that's 30, just under 39. That's just under 39. So the measurement between this inside, between this inside point here and this one is just below 39, which is 38.7. So let me just have a look at that. Now you see, what you're looking at is the 35 is the inside slot, right? The 35 is showing you the inside slot. It's not showing you the 2mm wall at the top and the bottom, right? There's a 2mm wall. The thickness of this, the wall thickness is the distance between this surface, right? This surface and the inside is 2mm, and it's 2mm between this surface and the inside surface. Okay, so there's 2mm between there and inside, and there's 2mm between there and inside. Okay, that's the wall thickness of this actual surface to wind the windings on here, right? This is how thick this surface is, 2mm. All I know is I've got the damn things in my hand. They exist. They're not falling apart on me. I just can't quite grasp what you're trying to say. I've already had enough trouble with this damn thing. Well, I can't see what you're trying to say. I'm looking at your picture and I just don't understand what you're saying. You see, the 5. Where are you getting the 5.5 from? Where are you getting the 5.5 from? I just don't get that. It was just a guess. Yeah, but like I said, there's a 2mm wall all the way around. Right. This paper roll. Oh, I've got that full of crap. Let me just use this bottle as an example. Right, this bottle has got a wall thickness. That's how thick the plastic is, but between the inside and the outside there's a wall thickness, right? Well, everything has a wall thickness, and you've got to take into account the wall thicknesses as well. And these flanges are 2mm thick. If I measure this piece here on this end, it's 2mm. It's actually a bit more than 2 actually. It must have. Oh, it's because this particular one's not a very good 3D printed one. There were some errors with this one. That one's better. Let's measure that one. That's 2. It's actually made them a bit bigger actually. It's like 2.5mm. But anyway, it works. That's all I know. If it's been modelled, it must exist because the program won't be able to create it. You want me to measure the width? Right, which way? What, this way? I want to measure the width that way? Or this way? The width is... Right, the width is... Right, 15, 16... Right, let me just get my rule at my magnifying glass. The width is 15, 16, 16.5. Alright. Where's my thing? That's what I've got on my program. The width between this side and that side is 16.5 millimeters. Right? I don't know if I can get this on camera. I'll try and get it on camera. I don't know if you can see the magnifying glass. I don't know. Oh, it glares. Just a minute. Hang on, let me get my preview screen up. Right. Oh, it glares at you. That's the trouble. Flipping ruler. Come on. I've got light refractions. I can't get it on it's just there's too much light. Hang on, shade it a bit. Right, hang on. Okay. Where the heck is... I can't get it on camera. Anyway, just take my word, it's 16.5 wide. The inside part where the bobbin the wire goes, which is wound around the inside, is... this slot is 3.5 millimeters on the inside, right? This part where you wind the wire on is, oh, if I can get it, 5, 6, 7.5, so it's 7.5, I think. That's right, isn't it? This inside part between there and there, let me just put it down so I can get my magnifying glass out. I can't see properly. Right, 5, 6, 7. There's a bit of swelling with the 3D print, so it's actually measuring 8. From what I can see, it's measuring 8 millimeters between that side and that side, that face and that face. It's 8 millimeters. This is on the outside. The inside diameter is 3.5 across that gap. The inside is 3. 1, 2, 3. It's actually measuring 3 on the inside. These have to be filed out, because when you get them printed, there's a bit of overspill on the printing, the 3D print head. You know, when it lays down each strand of what do you call it, the filament, it tends to splay out a bit, right? It bulges out a bit. It doesn't lay down in a perfectly straight walled thing, so that when it's printed, the walls are always a bit tighter than what they were supposed to be, and I always have to file them out a bit, which is no problem. I just get my rasp files and file them out. But these slots measure 3 millimeters wide when they're supposed to be 3.5, right? Except for this one, which I did file out. If you look, this one's been filed out because it was splayed out a bit, and this one's a bit tighter if you look, because that one had closed up a bit with the filament. It had overlapped, so I had to file that out with my 3.5mm file, which I've got. This one, it's raggy because of the filament overspill. Right, I've got to check the chart. The whole length. Right, the whole length on these were printed before I made changes though. These were done for the outside perimeter, and the whole length is gets lined up properly. It's 34. See, these were made before I made some changes. The whole length from that end to this end is 34 millimeters. Right? These were made previously. Right, 34. Now I made the whole lengths on the newer ones shorter because they have to fit. They have to fit in the smaller section for the inside because they can't overlap because they'll collide like this, look, right? There's no room. There's no room for these bobbins on the inside laminations coming out because they would collide, right? They'd overlap. You can't overlap. So I shortened them so they would become 30, so this total length would become 30, which basically means they will sit on that line there, right? This line here, which is 30 millimeters between my two fingers. So it would sit on that line, right? And they'll be inside slightly. And the other one would also just come up to that line, and it would just sit like sort of edge to edge like that. But this, as I said, this picture is a bit smaller than it's supposed to be. This actual printout is actually not to scale. So they would actually sit corner to corner on the inside. So the measurements for the new inside ones are bang on, but this is not exactly to scale because the this magnet holder is 92 millimeters. Oops, 92 millimeters wide, and this particular printout is 91 millimeters, so it's a bit under scale. It's close. It's a bit under scale. It's 91, but it's supposed to be 92. Don't know if you can see that edge there, but that's the 90 there. Where my nail file is, and then there's one. It's right on the 91 there. So it's slightly under scale size. This is. It's actually close, but very close. But it makes a difference. I lost my. Where's my preview gone? You talk about the width this way. Well, I've got no problems with the width because I haven't changed the width. The width is this way, right? It's between my fingers, right? That is the width that you're talking about. Not that way, that's not the width. That's the length. That's the length. That's the height. This is the height between my... This is the height between my fingers. Right? This is the length. And this is the width. Because the height is the distance it's travelling along the laminations. That's the way I worked it out. Is it? Oh, sorry. Yeah, it's my computer. It's just yeah, I'm just tired as well. I haven't got my CPU throttled on full. That's probably why. All I know is that these will work for the outside, and the inside ones will. The laminations for the inside, I'll have to have fewer laminations on the inside on the width there. So I might actually pull some of these peggings out and have them closer together on the inside. I don't know, we'll have to see. But they might be more condensed closer together, the laminations on the inside, but they'll be more spaced out on the outside. That's generally what you do in magnetic fields anyway. The magnetic fields expand, you see, and you have to shape the fields so that so anyway, the point is Alan's going to 3D print some test pieces for the inside ones, and when I get the test pieces I can put the test pieces on the inside and check the alignment and everything. But these widths, right, these actual widths, when I line them up on my drawing, sit exactly perfect. The slots sit perfectly in alignment with where the laminations would come out on here. I've had the light. I've held this piece of paper up to the light and looked down there, and they line up really well. You know, with where the laminations will come out. So the laminations will be between will actually be about, let's see, I've got my pen. Yeah, well, laminations will be poking out like this. So if I colour that in a bit, you'll see it better, because the switch part is in the middle there to the magnets, which is the magnets are on the inside there. So these are laminations which are 3mm, and down here 3mm, and down there. And if you look, those line up with the slots, and laminations lined up with the slots there, look. Okay, I think I've got this on the paper right. Yeah, that lines up. Yeah, but it's the angle of the camera is a bit hard to. I'll move this a bit directly underneath the camera. I don't know, is that right? Yeah, right. So I'm looking straight down on this and it's bang on. Well, the scaling's still a bit off on there, but actually that wants to be a bit further in. If there is a slight discrepancy, then all I have to do is sand these down so that they're closer together slightly, because these walls are quite, you know, as I said, the 3D print, when you get 3D prints made, it seems to add an extra thickness of about 0.5 mm on each side. So an extra 0.5 mm on these edges and an extra 0.5 mm on these edges will total 1 mm extra spacing further apart, which is another issue. But that's no problem. I'll just sand them down until these come together properly. But they're very, very close to where they need to be. I think it's about 0.5 mm out on each one. It's because of the way it's printed. 3D printers are not as precise as what people would have them be. Otherwise, I mean, it's not exact 3D printers. I wouldn't classify them as precision engineering. They're really for making toys and small models and things, but they're definitely not precision engineering because of the way the liquid, because it's liquid that's coming out. It's very difficult to control the flow of the liquid. Oh, it's all variable to the temperature and everything, isn't it? It's like if you get a pen, a ballpoint pen even, and you draw a line, you can't control the thickness of that line precisely because it depends how hard you press. It's the same principle. If you draw a line lightly, the line is going to be thinner than if you're pressing hard, which is a lot thicker. It's the same principle with a 3D printer. You know, the line can be very thin, and if you're building something up in layers with lots of thin lines, it's going to vary the thickness of whatever you're printing. So you can't, it's not precision, is it? It can't be. It's impossible to be. I think the only way they're going to be able to have precision engineered laser printing is if it's cut by laser in some kind of resin. Those new types where they actually point a laser beam in, and it might be to do that precision, but not with a nozzle. But so I don't know. Anyway, I'm tired. I've got to go to bed soon. I've got things to do. I've got the engineer coming round to look at my internet problems today. I appreciate it trying to help, Chuff, but I just don't think there's a problem there because it would have been flagged by the 3D printer guy when he did these, because you can't occupy the same space twice by two different lines, and if there was really a problem there, the 3D printer guy would have come back to me before and said, I can't print this. There's a conflict. But I didn't get a conflict then, and all I did to make these shorter was deducted the same amount from the inside as I did from the end length. So all the dimensions, the wall thicknesses are all the same, they haven't been changed. All I did was deduct something off the total length, both on the inside and the ends. That's all I did. I didn't change anything else outside parameters. What, that one? Oh, that one. I don't know which one you mean. What, the last one, this one? That's AB inside, that's inside perimeter. Back one. Outside perimeter. Oh, Which one are you talking about then? Are you talking about this one? The main one? You're talking about... I don't know what... Yeah, there's a lag. It's the flipping lag that's doing my head in. Right, look, they've got a name, right? This is the main one you're looking at right now. This is the outside perimeter. This one, right? Outside perimeter. Inside perimeter. Just tell me the name of the one you want me to leave on the screen. The name. What is, which one? Inside perimeter or outside perimeter, or the main one? Because of this lag, it's just driving me batty. Right, okay, thank you. Right, so you're talking about this one. You're saying that one's right. Well, I can't see what's wrong anyway, because, as I said, all I did was deduct a few millimeters off both the... I deducted exactly the same amount, right, off the inside and the ends, right? We're talking about, I deducted a certain amount of millimeters off there and off there, right? And that would bring everything into alignment without changing anything else, because the 2mm wall thicknesses don't change, right? So in theory, if I deduct 10mm off the 35, and I also deduct 10mm off the 48, they're still in alignment. So instead of 35, let's say it was 25, and let's say instead of 48 it was 38, you know? I mean, the wall thicknesses don't change. I'm still deducting the same value off both, so they should still be in equilibrium. I can't even say the word. Yeah, but I haven't changed that, and those have already been printed. The 16.5 is, I've never touched that. That's not been touched, and that's been printed already and came out without any errors, so I don't know what he's talking about, sorry. Are you talking about this 16.5 at the top? This one? Or this 16.5? Because there's two 16.5s. There's a 16.5 for the length, right? That's the length. And there's a 16.5 for the width, and that's that way. There's two 16.5s. Okay, Alan. I'll check email. Where the hell's my email gone now? I almost have closed it because I was getting ready for bed, wasn't I? Yeah, I think I did. The thing is, Alan's not spotted in it. He's not had a problem so far, so I don't know, Chuff. You must have got your numbers wrong somewhere, because I don't... You see, if it doesn't fit in the program, if it doesn't fit in the program, and the program will flag it and say there's a problem there, blah blah blah. Yeah, this bobbin's been driving me batty for weeks, and I finally come up with the right measurements, and now Chuff said there's a problem, and I don't know. Right, I really don't want any more problems with this bobbin. It's just... Right, can't find where... Oh, there it is. Right. Right, RE4, 4 parts and some question. I can't read that. Right, let's just save. And this one's called SB corrected. Right, let's find this. Oh god. Oh. Wrong folder again. Right. I can't drag and drop it. Right, let's just, that's open SB corrected, that one. Oh! Okay. Well, yeah, that's good, Alan, but you can actually surround that in a lamination with print material to make it stronger. I mean, the hole can go through the doesn't have to be hollow in there inside between this edge. I don't know. Doesn't need to be hollow between this edge and this edge. It can have a wall in there as well between there and the top. No, this drawing's got messed up. Just a minute. Let me just move this over. Right. Yeah, I can see, but yeah, it's good, but it's, well, I don't know. There shouldn't be a problem with that actually. If you can print, you see, I think you would have a problem printing that because of support material. You would have to have support material in, otherwise you can't print on thin air. That's probably why you're thinking of doing it in 2 halves. So I understand now why you were thinking about doing it in 2 halves. It's because of printing this top section. This top section would be a problem if you were printing that in thin air because it's hovering in mid-air. But you don't have to do that. You can have a wall. You can have a wall between here and here and the top section, which will be here. Oops, and here. So you can have a wall on the inside as well as the. So you can have support material going around this slot. Right. Think of this hole. Think of this hole in here as being like drilled through solid PLA, right? Because what surrounds that hole could be solid, but on the inside this part is clear like this. This is right. On this side this surface is correct, right? This is correct. So the windings will go around here, right? The windings will go around here. That's all correct. Well, yeah, you could put more material in there. Then you wouldn't have a problem with needing to do it into 2 halves. But yeah, I see what you mean. But that's very good. You've done a good job. That would still work. It would still work for me, but it would obviously be a bit more flimsy. Is my stream still working? Where's my preview gone? Where's it gone? That's definitely a lot better. Remember my other bobbins that I had made? Let me just get one. Right. Remember the round bobbins I had made? It's on camera right now. The slots for the laminations go through these holes, right? There's a hole in the middle, right? There's a hole in the middle. Then the solid material between the hole in the middle and the other holes, right, for the laminations, right? So the solid between the inside and these next other holes, and then there's 2mm wall between the outside holes and the surface of the bobbin for the windings. Basically it's the same thing that I was thinking about for the square ones, right? So you've got a surface to wind the wire on, which is solid all the way through to the holes. Then you've got these other holes going through, so that would make it a lot easier to print it as well. So yeah, you get the idea. I haven't got anything small enough to thread through this bobbin actually. My screwdriver's even too big because they're only 3mm. You see what I mean? Oh, sorry, sorry, Al. I did, yeah, I forget. It's because the camera's so close. I'll send you some Pepto-Bismol, I think they call it over there. Sorry. Oh. It's this huge lag. Yeah. Okay, Alan. Yeah, I've just been delayed going to get my sleep because Chuff was having a problem with one of my dimensions, but I'm pretty sure it's right because if it's wrong, it would be flagged by the software. Oh, it would come up with some kind of a glitch in the software, and then we'd know about it. So yeah, okay. Yeah, I need to go to bed. Yeah, because I've had enough. Right, good night, Alan. Turn my email program off again because I'm going to bed. I can use a drafting class. Yeah, you're probably right, but I didn't actually do drafting at school. But I'm doing quite well considering, though. There's one thing I didn't do at school. Well, I didn't do science. I didn't do. Well, I don't want to think. It's too old for me now. It's too late for me now. The school I went to, it was crap. I really.